The curve C has the equation y e to the minus 2x equals 2x plus y squared. Part A, find dy by dx in terms of x and y. So, I've got all my x's and y's mixed up here, so I'm going to differentiate both sides of this equation implicitly. Which basically means we differentiate across as normal, but when we differentiate a y term, we have to multiply by dy by dx. Now on the left-hand side here, we've got a product. We've got a product of two functions. We've got a y and we've got an e to the minus 2x. Therefore, I'm going to have to use the product rule to differentiate this. So I'm going to let u equal y and I'm going to let v equal e to the minus 2x. So differentiating the y, well, differentiating y with respect to y would give me 1, and then I have to multiply that by dy by dx. Now to differentiate the e to the minus 2x, the exponential differentiates to be the exponential, but then I have to remember to times by minus 2 because of the chain rule. So I then have u dash times v plus v dash times u. So I will have my 1 times dy by dx multiplied by the e to the minus 2x plus the y multiplied by the minus 2 e to the minus 2x. So that's the left-hand side there. On the right-hand side, differentiating 2x with respect to x will just be 2. Differentiating y squared with respect to x, well, differentiating y squared with respect to y would be 2y. And then because I've differentiated y, I need to multiply by dy by dx. So that has been differentiated now. Now all I want to do is move everything that has a dy by dx onto one side of the equation because I want to make that the subject. I want to find dy by dx in terms of x and y. So basically I'm going to take this term, move it over to the left, and this term here doesn't have a dy by dx, so we'll move that to the right. So we'll get dy by dx, e to the minus 2x, minus 2y dy by dx is going to equal 2 plus 2y e to the minus 2x. Next, I'm going to factorise the left-hand side to make dy by dx the subject. So I'll have dy by dx e to the minus 2x minus 2y equals 2 plus 2y e to the minus 2x. We'll now divide both sides. And that is the answer to part A. I have found dy by dx in terms of x and y. Let me just write that answer here. Right, part B. We're told that the point P has coordinates 0, 1, and we're told that we need to find the equation of the normal to the curve at point P, giving our answer in the form ax plus by plus c equals 0. So I've just worked out my gradient function in part A of the question. So I can use that gradient function to work out the gradient of the curve at point P. So at point P, 0, 1, dy by dx is going to equal 2 plus 2 times 1 e to the minus 2 times 0 divided by e to the minus 2 times 0 minus 2 times 1. So that's me just substituting the x and y into that gradient function. which will give 2 plus, well, 2 times 1 is 2. E to the power 0 will be 1. So e to the power 0 is 1, so times that by 2 is 2. On the denominator, e to the power 0 is 1, minus 2 times 1 is 2. So that's the same thing as 4 over minus 1, which is minus 4. So the gradient of the tangent is minus 4, which means that the gradient of the normal will be positive 1/4. The negative reciprocal of minus 4 is 1/4. I can now do y equals mx plus c with the coordinate 0, 1. So c is 1. My equation is y equals 1/4 x plus 1. And now just to write it in the required form, so times through by 4 and move everything onto one side. And we're done.